All right, welcome back. Today, we're going to tackle something a lot of us use, maybe even every single day. But do we really know how it works? I'm talking about VPNs. We're going to pull back the curtain and really get into how this thing creates your own private little superhighway on the internet. Let's get right into it.
You know the feeling, right? You click that connect button on your VPN app, the icon turns green, and bam, you're safe. But what actually just happened? What's going on under the hood? How does it magically wrap your entire internet connection in this cloak of privacy? That is exactly the question we are digging into today.
Okay, so first things first. Before we dive into all the geeky nuts and bolts, we've got to start with the big picture. Let's just lay a solid foundation here. What even is a virtual private network?
The whole concept really boils down to this one word: tunnel. Just picture it. The public internet is this gigantic, chaotic 8-lane highway where everyone can see everyone else's traffic. What a VPN does is it builds your own personal armored tunnel right through the middle of that highway. And inside that tunnel, your data is completely invisible. It's encrypted, totally scrambled, so nobody on the outside can peek in. It's virtual because it's built on the public internet, but it's private thanks to that super strong encryption.
So why do people and, big companies even bother with this? Well, the perks are pretty huge. For starters, it's way cheaper. Instead of building your own expensive private roads, you're just using the public highway system. Then there's the security, which is top-notch. It's also super easy to scale up. Adding a new employee is a piece of cake. And it works pretty much anywhere you can get online. So you get this amazing mix of being both cheap and incredibly secure.
Okay, but not all VPNs are created equal. They really come in two main flavors, or topologies, if you want to get technical. It all depends on what job they're designed to do. So on one hand, you've got site-to-site. Think of this like a permanent bridge between two office buildings, say, the headquarters in New York and a branch in London. That connection is always on. For the people working in those offices, it's totally seamless. They don't even know the VPN is there. Then you've got the other kind, remote access. And this is probably what you're used to. This is for one person, one laptop. You, at a coffee shop, connecting back to your company's network. You have to physically click connect and start it up yourself.
And even within that remote access world, you've got a choice to make, usually between two main technologies, IPsec and SSL. Think of it like this. IPsec is like being given a master key card at work. It gets you into every single room and works with every application, but you have to install and carry that special key card software on your device. SSL is more like using your web browser as a key. It's super convenient because you already have a browser, and it's great for getting into the main lobby, like websites and file shares, but it won't unlock every single door. It's that classic battle, right? Super tight security versus just plain easy convenience.
Now, since IPsec is such a huge player in the VPN world, let's zoom in on it for a minute. Let's look at its security toolkit. If the VPN is our armored tunnel, think of IPsec as the master engineering blueprint and the construction crew that actually builds it to be completely unbreakable.
So IPsec basically makes four big promises to you. Promise 1 is confidentiality. It scrambles your data with encryption so nobody can snoop. Promise 2 is integrity. It basically puts a digital tamper-proof seal on your data. This ensures that what you send is exactly what gets received. No sneaky changes in the middle. Promise 3 is authentication. This is the bouncer at the door checking IDs. It makes sure you are who you say you are and you're talking to who you think you're talking to. And finally, secure key exchange. This is maybe the coolest part. It's a super clever secret handshake for creating and sharing the encryption keys without anyone ever seeing them.
All right, so those are the four promises. Now, let's get even more granular. Let's pop the hood on the toolkit itself and see the actual tools, the protocols that IPsec uses to keep those promises. Inside this toolkit, you've basically got two main instruments, AH and ESP. Now, AH, it's a weird one. It's great at taking IDs and making sure nobody tampered with the package, but, and this is a giant but, it doesn't actually put the package in a box. The data itself is sent wide open, completely unencrypted. That's why pretty much everyone uses the other tool, ESP. ESP is the whole shebang. It does the ID check, it does the tamper-proofing, and it provides that absolutely critical encryption to keep your data secret.
And it gets a little deeper. IPsec can run in two different modes. First, there's transport mode. Think of this like putting your letter into a see-through envelope. The letter itself is scrambled and unreadable, but everyone can still see the to and from addresses on the outside. Then you have tunnel mode. This is like taking your original letter, address and all, putting it inside a locked metal box, and then putting that box inside a brand new envelope with totally different addresses on it. This is huge. It doesn't just hide your message, it hides who is even talking to whom, and that's exactly why tunnel mode is the go-to for those big site-to-site VPNs.
Okay, so we have the tools and the modes, but how does this tunnel even get started? I mean, how do two devices on the internet agree on all these security settings and secret keys without just shouting them out in the open? Well, that's where the final piece of our puzzle fits in. It's called IKE, the Internet Key Exchange. IK is basically a super careful two-step negotiation process. In phase 1, the two ends of the VPN meet. They show each other their IDs to prove they're legit, and then they build a small, temporary, secure tunnel just for themselves. It's like they're building a private, soundproof room to have a conversation in. Then, in phase 2, they step inside that secure room they just built, and now they can safely negotiate all the nitty-gritty details for the main data tunnel. You know, which encryption algorithm to use, how long the keys should be, all that stuff. It's all done in private.
And yeah, I really like this way of thinking about it. IK is the diplomat. It doesn't actually carry any of your cargo. Its entire job is to be the negotiator that hammers out the security treaty between the two countries. Or, gateways. It makes sure every rule is agreed upon before any of your actual, important data even thinks about entering the tunnel.
So, that brings us to the final big picture thought. We've gone through all this tech, right? We see how VPNs and IPsec can build this amazingly secure armored tunnel for your data. The engineering is solid. But here's the thing. The tunnel only guarantees a safe journey. It doesn't guarantee you're going to a safe place. The technology protects your data from point A to point B, but it leaves you with one massive question that no tech can answer. Once your data gets there, do you actually trust who's on the other side? That's something to chew on.